Thanks for tuning in at Brackies.
Hello everyone and welcome to video number 14 in the How to Program in C# course. In today's video we're going to have a look at interfaces. So an interface is basically like a contract that you can sign with a class saying what needs to be in that class. So if you look at an interface, it's very much like a structure of what methods and properties need to be in that class. So that sounds maybe a bit abstract to you, but basically you don't have to get very far in programming before interfaces become very useful for making things simpler, safer, and a whole lot cooler. So that's going to be awesome. And we are a pretty good way into the series here. So I quickly want to mention that if you go to brackies.com, I do have a donate button here where you can support Brackies. So you can simply click on that and it will take you to PayPal and you can donate any amount that you want to. All of the stuff that I upload is free. All of the assets on the Unity Asset Store is free and the assets pack. So if you want me to keep doing this for free, you can of course help me out by donating. So I quickly wanted to mention that. It's of course not something that you need to do, and I don't expect you to either. But if it's something that you feel like would be a good idea, I'm not gonna stop you. Cool. So let's dig right into today's video. So I've opened up Xamarin Studio here. And if we take a look at implementing a simple interface, we can basically describe an interface as kind of saying what should be in a class. And then the class itself describes how each method is implemented. So an example of an interface, we're going to create one here, could be, let's say, an item. So we wanted to have an item system and we wanted to define the structure of all items. Well, then we create an instant interface for those items, and I like to begin all of my interfaces with an I. So here's going to be item, just so we can identify them as interfaces. And then we open and close some brackets here. And inside of the interface itself, the syntax is actually really simple. We don't need to do any kind of availability layers, so we can avoid the public and private and all that. And basically, we just need to define the data type for the property. So we're going to have a string with the name of the item. And you can't just close this off. This has to be marked as a property, meaning that we have to do get and set. That's just a formality, but it's something you're going to have to do. And then we can also maybe make an integer with the gold value of this item, and that's also going to be a property. So we do the get set here. And then we can maybe make a couple of methods. So first off, we're going to have void, and this should of course be bool or float, depending on what you want to return. So we'll just say void here, and we'll make this equip. So we can equip our item, and another one for selling it. And none of these are going to take in any parameters either. That's also something you'll have to think about here. So that's a very simple interface, and if we wanted to implement this, we could go in here and define a class, and we could call this sword, and of course open and close some curly brackets, and in here we could create a public string name. And again, just simply let's use the default get set and a public integer gold value, and again use get set. Cool. And then we could go in and create a constructor. So we'll make this a public sword, and we're going to take in as an argument the name, so string name. So we can give it a name once we create a sword. And we're going to set name equal to underscore name, the name passed in, and we're going to set gold value equal to 100. So we'll just say that all swords in our game has a gold value of 100 imaginary dollars. And cool. So you can see here that we've now implemented the two properties, and we haven't yet implemented the methods. And the program is going to notify us of this. So if we save this and hit play, you can... whoa, this actually runs. Oh, I know why. It's because we need to implement the interface. Stupid me. So this is very central. Right now we just have a class definition and an interface definition. But if we go ahead and actually inherit from this interface, just like we've inherited from other classes before, so we can inherit from item here, then you can see that when we hit play, it's going to say that it doesn't implement the interface member equip. And if we click on this, you can see that it doesn't either implement the interface member sell. And if we didn't have these values or properties here, it will notify us to implement those too. Cool. So, and you might be thinking right now, well, why don't we just use a base class? And the reason for this is that we can use multiple interfaces that we can derive from multiple interfaces. And also this allows us to define how the actual methods and properties are going to work in the derived class itself. So now we can simply go ahead and make some fairly simple methods here, an equip method. And of course we don't have any logic for equipping items here, so we'll just write out that the name of the item and then has been equipped. And actually we'll just say equipped shorter. And then we'll have another method called sell. And this one is just going to say that console write line, the name of the item plus sold for plus the gold value plus imaginary dollars. Cool. And now when we hit play here, nothing is going to happen, but we don't get any errors. So now down here, we can go ahead and create a new sword. We can create a sword and we'll just call this sword as a reference, and we'll equal it to a new sword. Oops, not an S byte, a new sword. And we'll give it the name Sword of Destiny. And then we can call methods on this. So we can say that we want to equip this sword. And then we want to sell this sword. So now when we hit play, you can see that Sword of Destiny was equipped and Sword of Destiny was sold for 100 imaginary dollars. Cool. So that's the simplest use of an interface that I can come up with. And this works just fine already. But let's take this a step further. So I've drawn this thing in Paint. I know it's the most beautiful thing I've ever seen in my life too, but bear with me. So if we look at interfaces as like tags that we can apply to our objects, because right now we've tagged this class as an item. Well, we could also tag it as a quality. So we could basically say that this item has some kind of quality level and therefore should be able to be damaged. So we can add that kind of dimension onto the class. We could also tag it as part of a quest. So we could create another interface for that. And then we can basically have different items. So we can have a sword and an axe, and both the sword and the axe maybe are tagged as an item, of course. And we both want them to have some kind of quality level and be able to be destroyed when used. And But maybe only the sword is really important for one of the quests. The axe is just something we picked up, and therefore something we can just sell no matter what. So this is, you see, a piece of logic that is available in pretty much any RPG that I've played, at least, because it allows us to very dynamically use our code throughout our game. And then if we even go further with this, we can have an inventory with all of these items. So we can have an array of items, and then we can loop through that array and check what items are marked as part of a quest, and those that are, we can call a method on those items that only those items have that we want to turn in the quest items. So this might sound complicated, but I think we'll go ahead and implement this. So first off, let's create the quality layer, and that's going, or the quality tag, and that's going to act pretty much the same as our item tag. So we're going to have an interface here, iQuality, and I know the name here is not perfect, but we'll just go with iQuality. And this one is going to have some kind of integer, and we'll call this quality level. No, we'll call this durability. Actually, instead of quality, let's call this damageable. I like that a lot better. I should have thought of that so long ago. Okay, so interface damageable, and it's going to have an int durability, and it's going to of course have a getter and a setter, and then we can create a method that will say take damage, and it's going to take in an integer amount, and it's simply going to say that durability minus equals, and then we'll say 20. Oh no, of course, amount. Cool. So, and the name of this argument basically doesn't matter. That's completely irrelevant. And of course, this is on the implementation side. We just want to finish this off. I don't know. I got confused there, sorry. But basically, we do this structure where we want to have a void that takes damage. And we want to put in the amount as an integer. And it doesn't matter what you name this here, because we can just rename it or name it something different down here, and it's not going to throw any kind of errors or anything. So now we have this damageable tag, which forces our object or our class to include a durability variable and a take damage method. So let's now tag this with damageable, and now we can create a public void take damage, and it's going to take in the amount, or I could call this damage just to show you that that will work. I'm going to do that, and then we do the logic here, and of course now we want to name this damage, and we also want to implement the durability, so we can say public integer. And this is going to be called durability, and simply implement a normal get set. And we could do something here again with a private variable underscore durability that will make sure that durability doesn't go below 0 and all that, which you've seen in previous videos. So again, we have complete control over what this durability variable actually does, what its value is, and how we change it. Cool, and now down here we'll be able to, we'll say that we want to equip the sword, and then we want to damage the sword by 20. And whenever it takes damage, let's also print out that the name of the item, and then took or let's just say damaged by, and then we'll put in the damage amount, and then we say it now has a durability of, and then put in the durability. Cool. Yeah, awesome. So let's save that and hit play. Whoops. Expected a colon. I'm missing a plus sign there. Hit play, cool, and it says Sword of Destiny equipped. Sword of Destiny damaged by 20. It now has a durability of -20. Sword of Destiny sold for $100 imaginary dollars. Cool. So for some reason, okay, so durability of course defaults to 0. So up here in our constructor, we'll simply say that durability should be equal to 30 by default. And now you can see that it says that it has a durability of 10. Awesome. So that's kind of the idea, that we can create these tags and mark our items. And if we just take this whole sword class here and copy it down here, we can very, very easily create an axe. So it's again, that's going to derive from item and damageable. And this is also going to be axe. It's going to take in a name. It's going to start with a gold value of 70 and a durability of 50. And all of these implementations are going to be the same. And then down here we can create an axe, call it axe, set it equal to a new axe, and set its name to Fury Axe. And then we can maybe equip the axe. And we can, of course, damage the axe. And we're going to damage this by 10. And finally, we can sell the axe. So we can do all of the same stuff. And let's just make an empty line between these. So simply write out console.writeLine. And you can see that it does all of the stuff for the sword, creates an axe, and does all of this stuff for that too. So that's super cool, but that's just adding on to the amount of complexity that we have in our game. Next up is the actual very, very cool part of this. And that is marking these items as quests and then using that in our actual game logic. So if we should go ahead and create an interface here, the idea is very simple. We go ahead and create an interface called part of quest. And again, we do all of the brackets. We then create an, let's just create a void. We could have, of course, some more information like the name of the quest and all that. But here we'll simply force it to include a void called turn in. That will turn in the item. And that's basically all of this that this interface is going to implement. So, or all the classes deriving from this interface is going to be forced to implement, I should say. And now we can make our sword derive from this, but not our axe. So let's do a comma here and implement part of quest. And it's super cool, this idea that we can see all of the attributes of our sword right here. It also makes it very easy to read the code once it gets more complicated, and very easy to add functionality to a class. And then we simply want to include the logic here. So we'll make a public void and we'll call this turn in. And it's not going to take in any arguments. We're simply going to say that console.writeLine and then name of the item turned in. That's it. Cool. So now down here, our sword will be able to call the turn in method, but our axe won't. So if we try here, axe.turnin, you can see it doesn't autocomplete, and we would get an error if we tried that. So now let's see what we can actually do with this. So down here we can create an inventory, and we simply need to mark this, we need to make the type of item. So this is an array of items, meaning an array of classes that derive from the item interface. And this is simply going to be called inventory or items. And we're going to set that equal to a new item array, which is going to be able to store 2 elements. And in the first element, so index 0, we're going to set it equal to the sort that we've created. And the second index, or the second spot in our array, meaning index 1, is going to be equal to x. So both of these, these are different classes, but they derive from the same interface, and therefore we can add them into our array. And then we can loop through and turn in all quest items. So we can say for int I equals 0, I is less than inventory.length I plus plus. So this is a simple for loop. I hope you remember those. If not, go back and watch the video, because for loops are kind of essential. And then we simply want to say that, then we want to create an I part of quest, and this is going to store the quest item, and we're going to set it equal to inventory and then the index. And it's okay, so let me just explain what we're doing here. So we are creating an inventory, and that's going to act as an array of items, and it's going to have a total capacity of 2. The first inventory item we set equal to a sort, because that derives from item, and the second spot we set equal to x, and that also derives from item. Then we loop through all of the elements, and the element that we're currently looking at is called inventory to I. So when we go through the first time, this is going to be the first element, which is the sort. It's going to say inventory 0 here. And the second time, it's going to be inventory 1, which is the x. And then we try and put this into a variable of type I part of quest. And we call this the quest item. So if we just do this, it's going to give us an error, because right now the inventory item is of type item, and the quest item is of type I part of quest. But we can cast this object into a I part of quest by simply adding an as I part of quest. So now this is read as create a variable of type I part of quest and fill it with the inventory item of index I as an I part of quest object. So what this does is basically, if the inventory is marked with the I part of quest tag, if it derives from the interface, well then it's simply going to be transformed into the quest item variable. But if it doesn't, which our x doesn't, well then this is not going to work, and quest item is going to be equal to 0, because the x is not a quest item, and therefore quest item will be null. So now we can write if quest item is not equal to null, meaning if the object that we are looking at indeed is marked as a quest item, well then we can go ahead and make sure then we are sure that it has a turn-in method, and therefore we can call it. So now we can say that we want to call the turn-in method on quest item. So that is completely right, and this should work for any number of items that we decide to create. So let's try and run this and see if it's actually working. So let's hit play. And whoops, I just want to quickly make some more room here. And now hit play again. And you can see that we create a sort, and we equip it, and it says that it was equipped. Then we take some damage, and it was damaged. Then we sell it, and it says it was sold. Then we create an axe, we equip it, damage it, and sell it. And then we create an inventory array, which is basically an array of items. Then we fill in the 2 items that we have. Then we loop through it, and we check, and we try and force these items into a variable called quest item of type I part of quest. And then we check if that succeeded. And if it did, meaning it wasn't equal to null, then we turn it in. And you can see here that it says Sword of Destiny turned in, because that is indeed marked as a quest item. If we were to go up here and mark the axe also, so I quest part of quest item, and we were to create a method called turn in, again we could just copy and paste the method here, or we could make this completely different. We can say that name here turned in, and then we can say it was an axe. You can see we can change this how we would like. So now when we hit play here, it's going to go through and turn both of the items in. So when we play, it says Sword of Destiny turned in and Fury Axe turned in. Parentheses, it was an axe. Cool. So that is basically all I wanted to show you with interfaces, both the really simple way of looking at it as basically a way of making your code look cleaner and easier to follow, and the other way, which is using the inventory to kind of define how objects should interact. Cool. So thanks for watching. I hope you enjoyed this video. I hope you were able to follow it, even though some of the stuff showed here is actually fairly complex. I'm very proud if you've gotten this far into the series. So again, thanks for watching, and I'll see you in the next video.